Okay, this is on page 4 of the extra questions. It's got given, and then we've got the AM greater than or equal to GM for 3 variables. Prove, and then they've got this expression here. And you might look at the left-hand side and go, oh, A cubed plus B cubed plus C cubed, maybe I've got to use this. And if you use the AM GM for that, that would be the cube root of A cubed, B cubed, C cubed. But you run into a problem. We get this result here of that being 3ABC, okay, and that's completely different to the right hand side over here. And maybe you think maybe, well, I need to show that this is somehow bigger than this right hand side here, but that is extremely tricky and tough to do. Instead, my suggestion is let's have a closer look at the right hand side and have a bit of a focus on this first, maybe. Well, we definitely need to use the AM greater than or equal to GM, and that connects some sort of arithmetic mean with a geometric mean, which involves multiplying terms. And here I can see pluses in between, so maybe I just focus on one of these terms here where things are multiplied. So let's have a think. A squared B. Now we're told to use the cube root version. Well, that's equal to the cube root of A to the power of 6, B to the power of 3. Okay, so but we need 3 terms to add on the left hand side here, so maybe I can retreat this as A cubed, B cubed. Now I think I'm onto something. Okay, so let's have a look. In order to get that, we would have to look at A cubed plus A cubed plus B cubed and use AMGM on that. So let's do that. So that'll be cube root of A cubed, B cubed. And then we'd get that, I'll simplify, A cubed plus A cubed is 2A cubed plus B cubed is greater than or equal to 3. And that'll be A squared B. Okay, well, this is looking okay. So we've got the A squared B here. We've got a factor of 3, but I have a feeling that that'll divide out later on. Let's write the similarly and write the results for other variables here. So the next term has a B squared C. So therefore, following the pattern, that'll be 2 B to the power of 3 plus, and the other letter, C to the power of 3 greater than or equal to 3 B squared C. And the back term is C squared A. So that'll come from 2C cubed plus A cubed greater than or equal to 3, and that'll be C squared A, following the same pattern. And then what we'll do is we'll call that 1, 2, and 3, and we'll add them. And let's see what happens when we add. Hopefully you can see the division of 3, that each coefficient of each letter on the left-hand side will be 3, so we'll have a 3 there to divide later. So 1 plus 2 plus 3, let's just write it out in full. Plus 2C cubed plus A cubed greater than or equal to 3A squared B plus 3B squared C plus 3C squared A. And then collecting like terms on the left-hand side, we get 3A cubed plus 3B cubed plus 3C cubed, and we got greater than or equal to, and we can take out a 3 on that side. A squared B plus B squared C plus C squared A. And we can see the result. Coming out now, and we can divide by 3, and we got it. So that one was a bit tricky. You didn't use the obvious looking at the left hand side and going, oh, okay, so it's going to be A cubed plus B cubed plus C cubed on 3. You also had to kind of look at the right hand side and go, okay, so it looks like I've got 3 pairs here that have been added. Okay, often when there's 3 variables, it's 3 pairs that have been added. Focus in on one of the pairs and work backwards and think, okay, so how can I get that using this particular result here that they've told me to use? And then from there we could do the question. Okay, thank you. That'll be it for this video. all the best with completing the exercises.